Good evening. Today we're going to be talking about some more logarithm properties with expansion and condensing. So let's just hop into it. Um, it says in the instructions here, expand. We will, of course, remember that our three log properties are when we have something multiplied on the inside, we can write it as a sum on the outside. That we can take a quotient, divide on the inside, and turn it into a subtract on the outside. And finally, if we have a power, that we can turn it into a coefficient on the outside. And so we're going to use those three properties to solve every single one of these. In the case of the first six questions, we will be going from the first statement that I wrote to the second. In the lower ones, we'll be going from the second statement back to the first. So we're going to look at this as log 3 of 7 to the 5th minus log base 3 of 9. Then we'll take our power, we'll bring it down. And just like that, I've used the second property and then the third property. Now, it is worth noting that the instructions do not ask you to simplify. However, this can be simplified because logarithms are basically saying 3 to the what power equals 9. And if you're confused about that, then I encourage you to write it as log base 3 of 9 equals x, and then raise each power, exponentiate each power 3 to the log base 3. These cancel out, and we get 9 equals 3 to the x. Well, 9 is 3 squared. So if we wanted to, we could write log base 3 of 9 as 2. So the instructions don't specifically call for that, but because we can do it, we probably should. For number 3 here, we've got a triple product. So we're going to use the first property multiple times. I'm going to say this is log base 5 of w to the 5th plus log base 5 of g to the 3rd plus log base 3 of q. Oh, the first one should be a g, not a q, whatever. Okay, and then we're going to use our third property, the power thing, to bring these numbers out in front. So 5 log base 5 of w plus 3 log base 5 of g plus log base 5 of q. And I feel like my handwriting is sloppy, so I'm going to switch to the text tool, and you'll just have to handle the fact that this is inline text now. Number 5, 7/3 to the 6th. The easiest thing to do, we need to bring the power out front, so 7 log base 2 of 7 to the 3rd, which in turn we can write as a quotient, so it is 6 log base 2 of 7 minus log base 2 of 3. Those all need to be base 2. I'm not writing the base 2 because I'm using the text. So either that, or I guess you could distribute instead, and you can say it's log base 7 minus 6 log 3 if you prefer. One of these or the other. For number 2, triple product, this is going to be just like number 3. Log base 5 of x plus log base 5 of g plus log base 5 of y. Number 4, we do have an internal product, so we're going to start with that. Plus log of 8, and then we're going to say, but we've got a power, so let's use our third property and bring it out front. And number 6 seems like the easiest of the bunch because it's just a single product, so it's log of p plus log of s. And that should address everything at the start. Now, for the bottom, we're condensing. Condensing means we're just going the other way. So we'll generally do our coefficients out front first to simplify. So we'll say log of w plus log of b to the fourth. That number on the front comes in as a power. And then we'll say, well, we've got a sum on the outside. That means we can write that as a product on the inside. We'll do the same exact thing with number 9. We'll bring the 3 in as 3 to the second, which is 9. So let's just write 9 from now on. But now we've got a subtraction, which means it's like having a quotient on the inside. So it's log of 8/9. 11 log of 5 to the fourth plus log of 6 to the fifth, which I don't feel like carrying those numbers, so we're going to grab a calculator real quick to ask what is 6 to the fifth. 6 to the fifth is, oops, calculator work with me here. 7776. Okay, and you'll notice that I took this line, I went from writing it as an external sum to an internal product. And now we should be able to just like multiply these and get an astronomical number of 4861234. Okay. It's possible your teacher might have just wanted an answer of 5 to the fourth times 6 to the fifth. That is a perfectly valid answer as well, but typically when you have numbers, you're going to simplify them. All right, number 8, we have to do a little more work. Well, sort of. We're going to bring powers inside. And then we're going to say, well, this is a sum, so it's like multiplying on the inside. So we have d times y to the fifth times b to the third. Okay, for 10 and 12, it says ln. That doesn't change anything. It's just a very specific logarithm. So it's ln of 8 to the fifth minus ln of 9 to the sixth, which now we've got a difference on the outside of subtraction, so we're going to write that as a quotient. So 8 to the fifth divided by 9 to the sixth. And again, we probably should say what these numbers are equal to. So grabbing a calculator, because I'm sure not going to do 9 to the sixth in my head. We've got 32768 over 531441. And finally, for number 12, ln of x to the fifth plus ln of y squared plus ln of b to the third. And now we will condense them using the first property. And there we go. Okay, now, we've done all this, but I'm going to do one extra thing. I'm going to say, let's show why we might do a log property, why these are useful. So I'm going to hop over to a blank screen here, and I'm going to make up a problem, and I'm going to show you how log properties can be used. So let's suppose we have log base 2 of x plus log base 2 of, okay, I need to think very carefully to make these numbers work correctly. Let's say x plus 12, and this whole thing is equal to 6. Well, we're trying to solve this equation. That's going to be very awkward. But what we can do, this is parentheses x plus 12, what we can do is, normally when we'd have log base 2 of x, we'd say, well, let's do 2 to the on both sides. But that doesn't work out very nicely, because you can't simplify 2 to the log base 2 of x plus log base 2 of x plus 12. You could do 2 to the log base 2 of x and 2 to the log base 2 of x plus 12, but not 2 to the all of that stuff all at once. So what if we made it a single logarithm? And so we're going to use our log properties. We're going to say this is a sum on the outside. Let's raise a product on the inside. So base 2 of x times x plus 12. equals 6. And now we can do our 2 to the log base 2 of, and this is x squared plus 12x, is equal to 2 to the 6th. And so we can now just cancel our 2 to the out here, and we get x to the 12th, or x to the 12th, x to the 2nd plus 12x is equal to, and 2 to the 6th is equal to 64. So we'll bring the 64 over to the other side because now we have a quadratic to solve. And this can be factored. Factors of 64, 1 times 64, 2 times 32, 4 times 16, or 8 times 8. We need a pair that when one of them is negative, that we get a sum of positive 12. That's going to be this pair right here. So x plus 16, x minus 4. So seemingly x is either equal to 4 or negative 16. But not so fast. We have to remember that the numbers you plug into a logarithm can only be positive. If we plug a 4 into the original, we get log base 2 of 4 plus log base 2 of 16 equals 6. If we plug a negative 16 to the original, we get log base 2 of negative 16 plus log base 2 of negative 4 equals 6. And this right here does not work. Log base 2 of negative number, oops, we broke it. However, the first version does work because log base 2 of 4 is 2, and log base 2 of 16 is 4, and it's as simple as 2 plus 4 equals 6. So therefore, our answer is x equals 4. And these are questions that no doubt you will see eventually very soon afterwards, so we might as well start getting used to this idea. And there's where your log properties are primarily going to see value. So there is a rundown of a worksheet and also an idea of where to go from there. Thanks.